one had a common denominator, we can just top. The second one, we're subtracting, and we don't have a common denominator. Again, I'm putting brackets around those, because that gets grouped together. So when getting a common denominator, can you see that the first one is missing the x minus 5? So I'd have to multiply top and bottom by x minus 5. The second one is missing the x plus 3. Same idea as before when you're adding and subtracting, but now our denominators factors are bigger things. They could be binomials. Personally, I would leave this as a common denominator in factored form. Because if factored and there's something identical on top, you'd be able to simplify. Next, I would simplify the first one in just x minus 5. Keep my subtraction sign and simplify the second one, which would be 2x plus 6. The brackets are important here, especially in that second term, because that subtraction sign will go to both of those. So for our second one here, again, I leave this as x plus 2, x plus 5. Now I can combine my like terms. You see, you'd have x minus 2x would give you negative x. And you would have negative 5 minus a 6, which would give me negative 11. This is grouped together as well. And there's nothing we can simplify because there's no term that's identical. Number 3. Number 3 is the first one where factoring comes in. What we're going to want to do is, if we can factor, we're going to want to factor everything that we can first. So in question number 3, I can factor the bottom to x plus 3x plus 3 minus 2 over x plus 3. When I look at my denominators, they're not the same. But they both already have one x plus 3. You just need, in the second one, to add another x plus 3 to get our denominators the same. Again, I'm going to leave the bottom factored. Now that my denominators are the same. First one's just a 3. I'm going to put that in brackets. Subtract. I'm going to simplify this and keep it in brackets. 2x plus 6. Especially with subtracting, we have to remember you're subtracting all of this. Denominator stays the same. I'm going to get a negative 2x, and 3 minus 6 will give me negative 3. That's grouped together as well. You could factor out a negative if you wanted to, but nothing is identical on the top and the bottom, so there's nothing we can simplify.
Could you write the x plus 3, x plus x plus 3 squared?
You could write the bottom as x plus 3 squared. That would be fine as well. And the last one, number 4. Again, if we can factor, we're going to want to factor. So I have 5 over an x plus 3 minus, I'll leave some space in case I need to get a common denominator. 2, and this one factors as a difference of squares as x plus 3, x minus 3. Once they're factored, we see that they both already have the x plus 3. But I notice in my first one, in order to have a common denominator, it would also need an x minus 3. First one will be 5x minus 15, minus the second one, which was just a 2. Combine our like terms. And of course, the top gets grouped together. It can't be factored any further. None of the factors are identical. So that would be our final answer in simplest form. So what do we notice? The main difference in 7.4 is we're going to do exactly the same thing we did in 7.3. We are going to add and subtract, but we are going to add factoring so that when we get our common denominator, it's in the lowest terms. Just a connection to numbers, because sometimes it's nice to make connections to numbers. So for example, it had 5/6 plus 3/8. You've learned to find a common denominator. And the common denominator here is 24. But you also probably learned that sometimes it's easy to get a common denominator if you just multiply the bottom ones, right? Like if I multiply this one by 8 and this one by 6, I get a common denominator of 48. It's not the lowest common denominator, but it would still work. Okay? Option, which I think is the best one, where we said our common denominator is 24. That would get you to, in green here, multiply 4 over 4 would be green. That would be 20 over 24 plus multiply 3, 9 over 24. We would get a final answer of 29 over 24. Sound good? Okay. If you chose, and I'll do it in purple, if you multiplied and got a common denominator of 48, you would have had 40 over 48 plus 18 over 48, which would give you 58 over 48. And what's the problem with the answer of 58 over 48? It's not in lowest terms. You'd have to divide both of them by 2, get 29 over 24. The purple is not wrong, right? Because we didn't get the lowest common denominator, we had to simplify in the end. And it wasn't too bad. With numbers, it's not too bad. I will tell you, with algebra, it can get bad. Okay, we go up. Let's go to example 3. I'm going to erase it. I'm going to do it badly. I did factor. I left this as x squared plus 6x plus 9. And I wanted to get a common denominator. So I was like, well, this one's missing the x plus 3 now. And this one's missing x squared plus 6x plus 9 now. This isn't wrong, but this will end up bad. Okay? So now I have a common denominator of x squared plus 6x plus 9 times x plus 3. And on the top, I'm going to get 3x plus 9 minus 2x squared plus 12x plus 18. And you'll get a very big thing on the top and a very big thing on the bottom. And it won't be in lowest terms. So you'd have to factor harder things at the end. Sometimes you might even have to factor things you don't have the skills to factor yet. That's how bad it can get. You have to use grade 12 factoring skills if you screw up and don't factor first. Now, going back to our going back to our numbers. What you never did with numbers, but you could have, is you could have, and I'll do it in orange, you could wrote 6 as 3 times 2, and 8 as 4 times 2, or even 2 times 2 times 2. And if you did that, you'd be like, oh, what's missing in this one? Another 2 2's. What's missing in this one was just the 3. That's what we did originally in the green, right? You could just, but your number skills are good enough to see what's missing and say I needed to multiply by 4 and multiply by 3 to get 24. But we could break down into factors and look what's missing. That's what we have to do in algebra. In algebra, right, you haven't looked at your x plus 3 times table with all the other binomials that exist, right? It's just not something you do. So instead, we factor, and like we did in number 4, once it's factored, you're like, hey, this one has the extra x minus 3. In order to make them the same, I have to add an extra x minus 3 here. And so this is the next level of adding and subtracting. We summarize. We always need to factor first. Once we've done that, then we can get our common denominators. Oh, and then B adds the extra little note that we've run into before as well. So in part A, it's already, that's a factor, this is a factor. I'm going to leave some space. There's nothing actually to factor in part A. But then you look at your denominator, because we want to add fractions. And in order to add fractions, we need a common denominator. Do you see that this one is missing a p plus 1? So we multiply top and bottom by p plus 1. And this one is missing the p minus 2. by p minus 2. What do we get as a result? We have now a common denominator, and I'll leave it factored, of p plus 2 p minus 2. But in your numerator, we're going to simplify these. So p minus 1 and p plus 1 is the difference of squares. P squared minus 1. And p plus 3 times p minus 2, we can FOIL that out. And get p squared plus p minus 6. And as far as showing your work, I don't know if you've noticed that I left a little bit of extra space here, because we're going to write fractions, then on top of fractions, then on top of fractions. And if you don't leave a little bit of space, your brain might start mixing like where things are. So I just left a little bit of space. Still have my common denominator of p plus 1, p minus 2. Now when I combine my like terms, I'm going to get 2p squared plus p minus 1 plus minus 6 minus 7. And you're going to have to end by factoring if possible as well. Because who knows, maybe I could factor the top and something simplifies nicely. The top though doesn't factor. If you quick try to do the mental method of everything, every possibility, it doesn't work. So this is our final answer. And the textbook probably at the bottom. Did they write down principal values? There we go. Good practice. Say that p can't equal -1 and p can't equal 2. Right, so that was easy because it didn't involve factoring at the beginning. And then they really up the level when we get to question number 2. Oh, I need to make that smaller. That would have room to be right beside it. So the first one, nothing I can factor here. Minus. But the second one has a difference of squares. And right above this, when you see, and I'll underline them in purple here, when you see factors that are subtracted are almost the same except just flips of each other. One was 3 minus e, one is e minus 3. You can factor out a negative. So I'm going to factor out a negative. Oh, and I'm going to leave some space. I'm going to write 2 minus 2 over e minus 3. Leave some space for my common denominator. Then make my subtract. I'm going to factor out a -1. Leave me e minus 3. 3 plus e. And I have 3e on the top. This is grouped together. So they really up the difficulty by adding that special note in this one. But in order to add or subtract fractions, the rules haven't changed. We need to have a common denominator. So they both have an e minus 3. Can you see that this one is missing the 3 plus e? So we do the 3 plus e and the 3 plus e. Can you also see there's a -1 on the bottom? Negatives in fractions give you tons of options. Option 1, you could also add a -1 on the top and bottom here. And you have a common denominator with a negative. That wouldn't be wrong. If that's what you want to do, perfect. But I want you to know that if you have a negative in a fraction, so for example, if I have a fraction that has a negative on the bottom, that's the same as having that negative out in front. It's also the same as having a negative on the top. A negative in a fraction just means that fraction is negative. You can put it on the bottom, on the top, or in front. For me personally, in this situation, I would like to put it in front, because if I put it in front, what will that do my subtract sign? Change it to an add sign. So that's what I'm going to do. If you wanted to keep the negative on the bottom, make a common denominator with the negative, not wrong. Now I have my common denominator of e minus 3, 3 plus e, And if you wanted to write the second one as e plus 3, that's not wrong. My first one, when I multiply this out, is going to be 6 plus 2e. Now I have a plus sign. My second one was 3. I like terms on the top. 6 plus 5e, e minus 3, 3 plus e. This is grouped together. I check if any of my terms are identical, and they are not. So this is my final simplified answer. And of course, e can't equal 3, and e can't equal negative 3 are the non-permissible dots. Next year, this is going to bother you, because next year, you're going to learn that e is not a variable. It's not a letter anymore. In math, e is a number. On your calculator, find e on your calculator, put enter, it'll come out 2.71828. It's like a weird number like pi. So this question bothered me because I really felt like I was working with extra numbers. See if you can find it on your calculator. 3, 4e, 5, and 8 for practice.